So, you know how easy it is to get an AI to spit out a simple script, right? But what happens when you try to build a real application with it? Yeah, it gets messy fast. So today we're going to dig into a framework that's all about moving beyond simple prompts to actually architecting real software with AI. And this, right here, is the million-dollar question for so many of us developers. I mean, we've all seen those slick demos where an AI just flawlessly generates a little code snippet. But the second you ask it to build an entire application with, multiple files, it just completely falls apart. So what's going on here? Okay, so here's the paradox we're dealing with. Think of an AI coding agent like a brilliant but super literal junior developer. It's absolutely amazing at a tiny, perfectly defined task, like writing one single function. But when it comes to the big picture, the strategy, the architecture, it's just lost. It's like having this monster engine with no steering wheel. All right, so how do we give this powerful engine a steering wheel? Well, it all starts with a blueprint. Instead of just kind of winging it with vague ideas, we need to hand it these crystal clear architectural plans that spell out exactly what needs to be built. No ambiguity.
See, here's the thing. When our instructions are fuzzy, the AI has no choice but to guess. And on a big project, a few wrong guesses, well, that's a recipe for bugs, security holes, and just flat-out broken code. So the goal here is to craft instructions that are so precise, so perfect, that the AI doesn't have to guess at all.
And the first piece of this puzzle is what we call the spec. Just think of it as a formal specification that clearly describes what to build. Now, here's the really important part. A spec defines the what, not the how. We're basically telling the AI, here's the destination, but we trust it to figure out the best route to get there. Now, a simple spec is great for small stuff, but for big, complex applications, you're going to need something a bit more heavy-duty. And that's where the spec kit comes into play. It's basically a super structured template with dedicated sections for inputs, outputs, all the constraints, making sure there's zero confusion, even when you're dealing with a massive project.
Okay, so we've got our blueprint. Awesome. But just having the blueprint for a skyscraper doesn't mean it's going to get built right. You need a construction process. You need safety rules. So let's dive into how this framework handles that part of it.
Right, so just knowing what to build, that's only half the battle. The AI also needs to know the right way to build it. So the question becomes, how do we make sure it follows a consistent process? How do we get it to adopt a professional coding style? And maybe most importantly, how do we set up some hard and fast safety rules that it can't break? And the answer to that is spec-driven development, or SDD for short. This is a really formal workflow that just brings a ton of discipline to the whole process. The core rule is simple. No code gets written until a human has written a spec, reviewed it, and then locked it in. And that one simple rule stops the AI from ever just running off in the wrong direction. The whole flow is actually pretty simple, but it's incredibly powerful. First, a human writes the spec. Then it gets reviewed. Step 3, it gets locked down. This is huge, because it prevents that classic scope creep. Only then does the AI actually get to implement it. And finally, a human verifies the output. You see? It's this predictable loop that keeps the human firmly in the driver's seat, acting as the architect. So inside this process, we can get even more granular and fine-tune the AI's behavior using 2 key files. First, you've got SKILLS.md. Think of this as the style guide. It tells the AI how to think. Things like always prefer readable code. But then you have Constitution.md, and this is the law. It defines the hard lines, the things the AI is absolutely, positively forbidden to do. And let's be super clear here. The Constitution has nothing to do with style. It's all about safety. These are the non-negotiable, unbreakable rules that prevent total disasters. For example, you can forbid the AI from ever deleting data or exposing secret keys, no matter what a crazy prompt might ask it to do. Okay, so let's recap. Our AI has a blueprint and it has a set of rules. Great, but what's missing? Experience, right? A great developer learns and grows over time. So this next piece of the framework is all about giving our AI a memory. And this is a really, really critical problem to solve. You got to remember, by default, these large language models are completely stateless. They have no memory of what you talked about 5 minutes ago, let alone some big architectural decision you made 3 months back. So how in the world do we give our agent a memory so it can actually learn and improve? Well, the first part of the solution is something called prompt history records, or PHR.
This is basically a project-specific journal. It's really just a simple text file where you log the important decisions. Something like, decision, we're using Python, not Go for this service. Reason, we need to prioritize faster development. This kind of log gives the AI vital context for whatever it's working on right now.
But hold on, what about those lessons that aren't just for one project, but for all future projects? Well, that's exactly what reusable intelligence is for. This is a totally separate file that acts like the AI's long-term wisdom, its collection of best practices. So after a project wraps up, you might add a general lesson, like, hey, for all future command line tools, always return non-zero exit codes when there's an error. This is how you stop the AI from making the same rookie mistakes again and again.
So just to be clear, we've got two different kinds of memory here. The PHR, the prompt history records, that's your project-specific kind of short-term memory. It's all about past decisions on this project. Then you've got reusable intelligence. That's the general long-term knowledge, the lessons learned from everything it's ever done. And you really need both to create an agent that actually gets smarter over time.
All right, we are almost there. We've covered a lot. Our AI now has a blueprint, it has rules, and it has a memory. But right now, it's still kind of stuck in a digital box, right? It can't actually do anything. So this final piece of the puzzle is all about how we connect it safely to the real world. And this is the last big practical hurdle we have to clear. I mean, code is totally useless if it can't actually do something in the real world. Read a file, call an API, check on a server. But for very good safety reasons, AIs can't just do any of that stuff by default. So how do we give them these abilities without just blowing a massive security hole in our system? The answer is something called the Model Context Protocol Server, or MCP server. The easiest way to think about this is like a secure, heavily audited gateway. The server is the bridge that gives the AI controlled, permission-based access to real systems, like your Git repo or a Kubernetes cluster. It's what gives the AI tools to work with, but with really strict limits that a human sets. Whoa, okay, we've just covered a ton of different ideas here. So for this last section, let's just lay all the pieces out on the table and see how they click together to form one complete, cohesive system for directing an AI agent.
So let's put this whole thing together. At the very center, you've got the AI agent itself. That's the engine that writes the code. The spec is its blueprint. It defines what to build. The SDD process is the project manager, controlling when it builds. Its whole personality and behavior is shaped by the skills and Constitution files. That's how it works. Its memory is built from those project histories and the reusable lessons it learns. And finally, that MCP server is its connection to the real world. You see how that works? Every single component has one and only one clear job.
So if you take away just one thing from all this, let it be this. Getting amazing results from AI agents isn't about chasing the one single perfect prompt. That's a losing game. It's about building a system. It's about creating an architecture that cleanly separates the AI's main job, which is execution, from the rules, the memory, and the process that guide it. The moment you stop just prompting and start architecting intent, that's when you start getting predictable, reliable, and incredibly powerful results.